Hey, Prashant sent this question from 2010 about probability density function. So let's take a look at this. This is a good one to review. Remember, a probability density function is some curve that gives the probability of something happening, and that probability is going to be the area under the curve from 0 up to that point. For example, it's told to us that the probability that x is less than 1, so let's say 1 is right here. So the probability of an event being 1 will be the area under the curve from 0 up to that point. And that's given as 1 minus 1 over root 2. So the first part of this is they give you the probability density function up here, but they've included a, and you're supposed to find the value of a in part a. So you know that if you integrate this function from 0 to 1, it's going to give the probability up to 1 of the function a e to the negative ax. So we're going to integrate that, and we'll set it equal to 1 minus 1 over root 2, because that's the given probability. So this integration is not too tough. Anytime you integrate an e function, remember it is itself. So when we integrate this, we're going to get a e to the negative ax, which is itself, over the derivative of the power, which is negative a. And that goes from 0 to 1. Let's simplify that down. The a's cancel. So we have a negative sign, which I'll float up to the top. So let me come down here. It's negative e to the negative ax, and that is going to be evaluated from 0 to 1. So if I put a 1 in there, I get negative e to the negative a, and if I put a 0 in there, I get minus e to the 0, and e to the 0 is 1, so it's minus 1. So on the top, I've got negative e to the negative a, and on the bottom, I've got negative 1. And remember, when you evaluate an integral, you subtract those two. So if we subtract the 1, negative 1, it becomes plus 1. So that's going to give us negative e to the negative a plus 1. So that's the integral from 0 to 1, and we know that has a value. It was given to us as 1 minus 1 over root 2. Well, take a look at that little equation. The object is to find the value of a. We'll solve for a. First, let's just get those 1's out of there. And we have negative signs on both sides, so we just are going to be left with e to the negative a equals 1 over root 2. And if I reciprocate both sides, e to the negative a flips over. So it's 1 over e to the a equals 1 over root 2. So in other words, reciprocate again, e to the a equals root 2. Take the ln of both sides. A ln e, which is 1, equals the ln of root 2. And of course, the natural log of the square root of 2 is the same as 2 to the 1/2. And the property of logarithms, we can take that power down front, is 1/2 ln 2. So we have shown what they want us to show. Okay, that part's done. Okay, now for part B, it wants us to find the median of x. Well, the median is half the probability, so we'll just take the integral from 0 to m, which is halfway, and set it equal to 1/2. So let me scroll down here and get a little room. Now in writing that integral, I'm going to put the a back in. I'm not going to put the value of a in it. I'm just going to rewrite it the way it was originally written. So the integral from 0 to m of a e to the negative ax dx has to equal 1/2, because the median is halfway within the integral, within the probability. So we've already done this integral once, so why do it again? We know the result is negative e to the negative ax. And this is going from 0 to m, and that has to equal 1/2. So we're just going to solve this for m and find that midway point, that median. Well, subbing in m, we get negative e to the negative a times m, and then subtract the lower bound, which is negative e to the negative a times 0. That's got to equal 1/2. Well, the second part again, e to the 0 is 1, so we're subtracting 1, but we're subtracting a negative 1, so that ends up being plus 1 equals 1/2. So we have negative e to the negative am. Let me subtract that 1 over to the other side, so it's got negative e to the negative am equals negative 1/2. And cancel the negatives on both sides, and I'm going to come up here. So what do we have at this point? We've got e to the negative a times m equals a positive 1/2. Well, any negative power means this has been flipped over, so 1 over e to the negative am, except the negatives have gone now, so that's positive, equals 1/2. I'm going to reciprocate both sides. E to the a times m, we're getting closer, equals 2. Take the natural log of both sides, and we get am, I'm switching my style of a for some reason, equals ln2. Scroll down just a little bit. Okay, now I'm going to put that a value back in. I got to see what it was. It was a is ln2 to the 1/2. ln2 to the 1/2. I'm going to pull that 1/2 down front. Times m equals ln2. We have ln2 on both sides. Cancel, cancel. This is a 1 on the right now, so I'm going to multiply both sides by 2, and m is 2. And there is the answer to part B. This problem's getting a little messy, but it's really pretty simple the way it falls out. Part C is worth 9 marks. It's really not any harder than the other two parts. In fact, I think it's a little bit easier. Calculate the probability that x is less than 3 given that x is greater than 1. Probability x is less than 3. I'm going to write that as a conditional statement. Less than 3 given the probability that x is greater than 1. Well, that's a given statement, so we use the fact, our formula, the probability 3 given 1 would be the probability x is less than 3 and probability that x is greater than 1 over the probability that x is greater than 1. Well, think of that numerator. Probability x is less than 3 and x is greater than 1 would be the integral between 1 and 3. So that's greater than 1 and less than 3, or less than 3 and greater than 1. Same thing. So we're going to integrate the probability density function, and again I'm just going to go back and use the a within it to keep it just a little bit neater. It's easier to deal with without putting the a value in until the very end. So at the top, the way I've got it written with that integral is now the probability less than 3 and greater than 1. Probability greater than 1, well, we were given less than 1 up here. Well, if less than 1 is that, remember the whole probability of the entire function has to be 1. So greater than 1 is going to be 1 minus 1 minus 1 over root 2. And then the 1's just cancel, and you're left with 1 over root 2. So the probability that x is greater than 1 is the complement, which is 1 over root 2. So all we have to do at this point is evaluate that numerator and simplify this messy thing down. So again, we've done that integral a few times. So again, it's going to be negative e to the negative ax, and we're going to evaluate it from 1 up to 3. So subbing 3 in, we get negative e to the negative a times 3, and subbing 1 in, we get negative e to the negative 1a, and we're going to subtract those. So carefully watching those signs, we get negative e to the negative 3a minus the negative, so that becomes plus e to the negative a. And I think I'll just go ahead and clean this up a little bit. Remember, this is our big numerator in the problem. So I'm going to rewrite this as, let's see, let me flip those negative powers. So it's going to be negative 1 over e to the 3a that's the first one, plus 1 over e to the a. Now, I think I'll get a common denominator. I'm going to multiply this second one by e to the 2a, top and bottom. So now I've got negative 1 plus e to the 2a all over e to the 3a. Now I'm going to put my, remember what we're doing here. This, you can get lost here. That's the numerator. I'm still working on the numerator, trying to clean it up. At this point, I'm going to put my a value back in, and let's see, what was a? I got to scroll up and look at it again. It's 1/2 ln 2. So I've got negative 1 plus e to 2 times a, which was 1/2 ln 2, on top, and e to the 3 times 1/2 ln 2. Okay, well 2 times 1/2 ln 2 is just ln 2, and e to the ln of anything is that number, so on the top we have negative 1 plus 2. On the bottom, I'm going to multiply that 3 times the half, so that's e to the 3/2 ln 2, which is e to the ln 2 to the 3/2, and e to the ln of anything is that thing, so what does this clean up to? So negative 1 plus 2 on the top is 1. On the bottom, e to the ln of 2 to the 3/2 is 2 to the 3/2. Okay, so that was my entire numerator of the formula for the conditional probability. Now that's all over 1 over root 2. So I've got 1 over 2 to the 3/2 over 1 over root 2, which is 1 over 2 to the 1/2. So I can do a little algebra here. 1 over 2 to the 3/2 divided by the fraction. I'm going to reciprocate it, so that's 2 to the 1/2 over 1. We have the same base of 2, top and bottom, so we subtract the powers. So that's going to be 2 to the negative 1, and 2 to the negative 1 is 1/2. So that's the conditional probability from the original statement. The probability that x is less than 3 given that x is greater than 1. Well, yeah, not hard, but gosh, I can see why that's worth 9 marks. It's awful messy. But if you can just stick with it, you're going to get the right answer. Well, finally, this problem is done.